Okay, the stuff we're going to be looking at today is much the same as what we looked at yesterday. This is changes to the quadratic equation as different little constants and values can show up in our quadratic equation. Okay, so yesterday we kind of talked about it, got a little familiar with it. Today we're going to be doing some graphs that deal with it. Okay, so follow along on your paper there, of course, exploration of parameter changes on quadratics. The quadratic parent function, if you haven't figured it out, is this guy, y equals x squared. Nothing changed about it, nothing added to it, nothing multiplying times our independent variable x. It's a positive x. That's what makes it a parent function. The basic graph can be transformed using parameter changes. Okay, and those parameter changes are what happens when we start playing with this constant a in front of the independent variable, and what happens when we start playing with adding or subtracting a number from the equation itself. Okay, so the following problems investigate the effects of the parameter changes on the parent function. Okay, now what we're going to be doing is, of course, the instructions say here, use the graphing calculator to help you sketch a graph of each function below. Label each parabola with the correct function's name, and optional, use different colors to distinguish between the graphs. Now, what you're going to see is at the top of your graph right there is you have 6, 7, however many it is, different parabolic equations. They're going to graph parabolas. Okay, you're going to graph all 6 of these into the one graph that's provided there for you. Now, the instruction did say to use your calculator to help you create a sketch. Now, let me clarify what it wants as far as a sketch. I do not want people to go, okay, let me grab my calculator, if I can find it. Where's my calculator? There it is. Okay. I don't want people to grab their calculator and go, okay, the first equation says y equals x squared. I don't want you just to come into your calculator, type in x squared, hit graph, and go, okay, well, it does that, so I'll just come to my graph and I'll draw something kind of that looks like that. That's not at all what it means when it says sketch. Okay, this graph hits particular points. Okay, this parabola hits particular points in the graph, and when you draw it on your page, it should hit the same points. Now, how do you figure out which points it hits? Well, it's really fairly simple. We can pick some points, okay, on the x-axis, and we can plug it into our equation, okay, for x and find out where those points are plotted at. Or, if you're not familiar, once you have the graph in your calculator, like we do right here, right now, you can use the table to tell you various points that are on the graph. So what I want you to do is either by plugging in values for x, okay, values that you make up and plug in, or whether you use the table on your calculator, okay, I want you to actually plot points in your graph. Okay, so in this particular case, instead of just swooping through the graph and drawing what you hope to be the correct parabola, I want you to come in and find the actual points, 0, 0, and put a point, 1, 1, put a point, 2, 4, and I want you to do this for as many points as can actually fit in the size of the graph that they gave you. 4, 16. Oh, well, that's off the graph, so we won't worry about that one. Now, that's all the positive side points. What about the negative side points? Yeah, remember, they're in your calculator, even though the screen may not show it right now. Okay, you just need to scroll, okay, backwards. Okay, it was only showing us the positive numbers. Now we can get some of the negatives as well. -1, +1. Oops, I put it in the wrong place. -1, +1. -2, +4. -3, +9. Okay, and -4, 16 is off the graph. And there's that symmetry that we talked about. Notice how it's the exact same on both sides? But that's what I want to see for each of these equations. That's what your first equation is going to look like. And the problem, the instruction set said to label the graphs as you draw them. So as we drew this one, what we'll want to do is we'll say, all right, somewhere near one of the legs of the parabola there, well, we'll put the equation that goes with it. Okay. Now you're going to end up with 6 different equations in your graph. It's going to get awfully cluttered. And as the instructions said, use different colors if you would like. Okay, well, I'm going to change that to go ahead and use different colors. I have sets of map pencils here that we can use. Okay, so when we draw this, we can actually tell which equation is what. And when I grade it, I'm going to want to see which equation actually goes where. Okay, so we're going to make sure that we can see the points that actually do go with that graph. We'll sketch the graph connecting the points. We'll label the graph, and that's pretty much all it is. We're exploring these different changes with these different equations, one equation at a time, seeing what the graph is going to look like. Okay, so that's what we're going to do today. That's everything that you're unable to finish during class time, which I think you'll be able to finish this. You'll need to finish it at home.